Looking at the schematic of the test section, you can see that the model, you need to mount your model in some way. So there's lots of technology in a wind tunnel that you can see when you look at the test section. So let's start, for example, with the model motion system. There are lots of different ways of mounting a model in a wind tunnel. The aircraft industry would tend to use a sting that comes into the tail of the aircraft so that you have the minimum aerodynamic interference. Mount systems for wind tunnel models of race cars, we've tried every type of mount that you can think of. Wires suspending the model from above, which is quite difficult to manage, not particularly rigid. It's a technology we'll probably investigate again in the future. A sting coming into the tail, like the aircraft industry we've tried. Mounts either side of the model, mounting the model from arms on the wheels, and in the end, the system that appears to give the least overall aerodynamic interference into the flow around the car is to mount it from above in somewhere around the middle of the model. It's not that we haven't tried other methods, but it's about the most about the best way. However you organise your model, now we use what's called a hexapod, but however you mount your model, you need to be able to move it up and down. You need to be able to yaw the model. You need to be able to roll it. You need to be able to pitch it. Then we have many other degrees of freedom. For example, you can steer the wheels, but that's we do from the model. The hexapod has certain advantages structurally. It's quite stiff. It allows you to do most of your motion from above. So with a hexapod, you control the roll by moving the hexapod sideways like this. You control pitch by moving the top of the arm fore and aft. Yaw is done lower down. You can do yaw from literally within the model. So you can, within the model, you can just decide to yaw it from within. On ours, we have the yaw point a little bit higher up, and we yaw it from a point here. So most of the model support is aerodynamically aligned with the airflow, and only the bottom part moves the model. So these systems are computer controlled, reasonably rigid. They're actually quite heavy, but the weight doesn't really matter unless you start to move really quickly. And we move at a controlled pace. We don't move violently, dynamically quickly, but we move continuously and reasonably quickly. We have wheels mounted on our model. I've worked with both wheels mounted on model and wheels remotely mounted on arms, so that the vibration and the inaccuracy, if you like, caused by the vibration of the wheels is not transmitted to the measurement systems on the model. But we found over time that the absolute accuracy of having wheels mounted on the model outweighs the slight measurement repeatability problems you have when the vibration of the rotating wheels just slightly reduces your ability to repeat precisely a test. And that's been achieved through experimentation. You try both systems, you see which gives you the best results. And now there is such importance placed on the aerodynamics of the wheel and how that changes the airflow around the car that you really, I feel, need wheels on model. The wheels are turned by the rotating belt. The tyres are supplied by Pirelli as part of our contract with them. All teams are supplied by Pirelli with both their race tyres and their model tyres. The model tyres have their own technology. The tyre supplier does have to think hard about how to design the tyre. It's not just a scaled version of a race car. So we are supplied up to 12 sets of tyres per year to do our wind tunnel testing. And in the past, when wind tunnel testing was not limited, those tyres would have to do of the order of 50 to 100,000, and some sets would do more than 100,000 kilometres of testing in the wind tunnel. A set of race tyres, a race is 300 kilometres long, and you have to make pit stops. So the longest you're going to do on a set of tyres is just over 200 kilometres, is all a set of race tyres will do. The model tyres have to do, not 100 times, but they have to do a lot. Sorry, not 1,000 times, but nearly. So the tyres have to be different also in their durability, and that means it's quite difficult to simulate exactly what a tyre does on a race car, and that's why Pirelli spend energy designing different model tyres to the tyres that you use on the racetrack. I'm giving the game away now. I'm going to ruin the future of aerodynamics.